cluster service row, I have that already. And EKS cluster. Next, my VPC is Frank VPC. These are my subnets. Security group is Frank SG. Public and private. Next. Next. And next. And next. And create. Right. So while this guy is creating, let me run and create one EC2 instance that we'll use for managing my cluster. Hey man. Instance let me call it remote VM Amazon Linux 2. Be careful of this guy, yo. Amazon Linux 2023. All right, be careful of that guy. It doesn't have a lot of features. All right, so always Amazon Linux 2. Okay, T2 Micro, keep Frankie, network settings, Frank VPC, sub security group, Frank SG, and that is it. So on this node, I'll be installing AWS CLI version 2 and then kubectl. That's all I need. Remote VM, where are you? Refresh. So waiting for our guy. All right, so it's running. Copy. And what is it? Broke. Okay, but don't finish now. Don't finish. All right, so let me use this first page. Paul, log out, can't log in again. Good morning. Log out, log in again. Log out and log in again. Because the guys here can hear me. So let's check the version of AWS version -v. All right, 1.18. So I need to install, upgrade it to 2 points. Google AWS CLI install. AWS CLI install. Then kubectl AWS install. Same. The CLI Linux 64 bits copy. Come over here and paste that. Paste it. No time. Hit enter. Bam. So let's try that again. AWS version. So exit and come back in. Now try it again. AWS version. We're having version 2. Now we need to install CLI. CLI AMD kubectl 1.28. 1 second, guys. kubectl 1.28. kubectl 1.28. Let's go there. Then go to B. B is optional. Go to C. Copy C. Come over here. Paste that. D. Copy D. Paste it. And E is optional. Then 3, check the version. Perfect. So we have AWS kubectl version 1.23. So we are all set, guys. We are all set. Let's check our cluster. Is it active? It's still creating. Take some time. Still creating. Still creating. All right. So while we are waiting on the cluster to create, let's look at what we have. Ports overview. So we will be talking about ports today, ports and services. All right. And if time permits, we shall also talk about replica sets. All right. Replica sets. Down. All right. So we have started a journey into Kubernetes. All right. So for that reason, I have a study plan for the Kubernetes. So I have a set of images we are going to be using. Let me check that guy. Canada. One sec, guys. I want to go Canada. Canada. Okay. Right, this port web app 0 9 this thing now. All right. I've got some set of images. Okay. Okay, so let's check our cluster. Refresh. It's still coming up. Should be active very soon. Very soon. Right. So as we all know, pod, all right, is the smallest unit of objects in the Kubernetes cluster. So we explained that when we were talking about Kubernetes objects. All right. So going further from today is just implementation, right? Because we took our time to explain a lot of the objects. All right. So if it's something that you need to revisit, I'll advise you go back and watch that video. All right. So what we're doing today is how to write the manifest and how to get information on writing the manifest for these different objects. All right, great. So yeah, so when we say manifest, Kubernetes manifest is one way through which you can install an application into a Kubernetes cluster. That's the meaning of manifest. And manifest uses YAML. All right. So the content of a manifest is YAML. It uses YAML. YAML is yet another markup language. YAML is so simple, straightforward to understand, right? Because it's very close to English language, very close. The structure is very simple, right? And very understandable. Sorry. Okay. Then there are other package managers like the Helm charts, HELM, Helm. Helm chart. So Helm chart also is used to install packages into what? A Kubernetes cluster. Maybe at the end of these Kubernetes, we shall look at Helm charts, all right? Should be the last thing we'll look into. But all through, we will be using what? Manifest. We're using manifest. All right, so let me check the cluster. Should be active. Yeah. So our cluster is now active. So now let's go to what? Compute, so that we can add the node group. Okay. Add the node group. Add the node group. EKS worker. Node role. EKS worker role. Next. The AMI type is that Amazon Linux 2, which is there already by default. The capacity type is on demand, right? So if we're taking spot instances, right? So spot instances are instances that are required, that are used whenever they are required, right? So when they are not active, they get terminated, right? Those spot instances are cheaper, all right? They are cheaper depending on the kind of architecture and depending on kind of environment, all right? So let's stick to on-demand instance. Then T3 medium is basic. The disk size 20, that's okay. My desired size of the nodes is 2. I want 2 number of nodes. I want minimum of 2 number of nodes as well, and maximum of 2 number of nodes. So this means that at every point in time, there will be only 2 nodes running, minimum of 2 nodes running in my cluster. If I delete either of the nodes, automatically Kubernetes node control plane, node controller is going to spin up a new node to make sure that it is 2 that is running at every point in time in my cluster. These 2 nodes. I think that's all. Click on next. The subnets, same subnets, next, and create. All right. So while this guy is getting created, all right. So let's go to my what's it called? My remote machine, and I'm going to download the kubeconfig file. So for that, I'll say kubectl update, sorry, EKS EKS abi should have comes first. Update kubeconf, update dash kube dash region is EU West 1. Then the name of the cluster is EKS cluster. EKS cluster. Oh, sorry guys, sorry. Hey, AWS EKS. I wonder now, Benny. Kubeconfig dash region. And don't forget, I never practice this one, Abi. Gonna sister they make mistake. Now practice so EKS cluster. So oh. Why am I getting this error, guys? Why am I sorry?
You never use the user signing to AWS for say like
I never authenticate, Abi.
yeah.
Yes, so I need to authenticate. Guys, please take note though. Take notes. I need to authenticate. So I'll go to I am. Where are you? Come to I am, duplicate. Go to I am. All right. Security credentials. Don't put the Okay. Oh, man. All right. So credentials, access key, CLI, confirmation next, create. So copy, come over here and say what AWS configure. You paste that, copy the secret key over, you paste it. My region is EU West 1. The output is JSON. So now if I say AWS STS, STS is secure token, what was that thing again? Static tokens ability, what was it? Can someone remind me? STS. Can someone remind me? Security token service. All right. Do not forget security token service. AWS STS gets caller identity. So the guy is what? Omero, and he is the guy that created the cluster as well. So now I can run AWS EKS updates dash kube config dash region is what? Is EU West 1 dash name is what? EKS cluster. So what I'm doing now, I'm downloading the what? The kube config file from the control plane to my what? Base machine. So now I have what? That file under this directory config. You can see it now. It's under this place now. Enter. So this is the content of the file. All right, that's the content. So now if I can now run kubectl commands. So I can say kubectl get node. All right. So my nodes are up and they are ready. Let's check. Let's check. So if I refresh, my nodes are up and ready. EKS cluster, compute, they are now what? Ready. All right. So now at this juncture, we can now start playing around. Before we play around, let's check out for other things. kubectl gets SVC. I showed us a lot of shortcuts last time. SVC is what? Is shortcut for service. All right. So get service in the default namespace. All right. So default namespace is what? Is default. If you're not specifying any namespace, any flag, so the namespace is default. So kubectl gets namespace. NS is a short form for what? Namespace. So these are the namespaces that I have. I have the default. I have kube node lease. I have kube public. I have kube system, right? So if I want to see the ports running in the kube system, I'll say what? kubectl get ports. Short form for port is PO. Get port in the flag namespace kube system. You can see. So these are all the ports running in what? The kube system namespace. So if I need to get everything, I'll say kubectl get all. Get all means get all objects. All objects definition in that namespace, in the kube system namespace. So I'm going to get a lot. I'll be getting, these are ports, these are services, these are daemon sets, these are deployments, and these are replica sets. So these are all the objects that are currently running in the kube system namespace. All right. So what we have today is writing a pod manifest. All right. So guys, I need to show us how to get the documents to use for writing what? A pod. So I'll go to Google and I'll type what? I'll type Kubernetes, Kubernetes pod. So if you need to get any documentation for any service, for any Kubernetes service, all you need to do is just to type Kubernetes, then the service name, the object name, Kubernetes deployment, Kubernetes ingress, Kubernetes daemon set, Kubernetes stateful set. You will get documentation. You don't need to go and cram anything. Don't cram, guys, but you just need to know what you're doing. Okay, now let's get started. So Kubernetes pod, I'll hit enter. All right. All right. So you always see kubernetes.io. This is the official document of Kubernetes. And this is what you're looking for, pods Kubernetes. So right click on it, open in a new tab. Let's go there. All right. So pods are some or less deployable units of computing that you can create and manage in your cluster. All right. Right. So let's scroll. Now, this is everything about pod. This is basic though. All right. Because when we shall start, even in production, you won't be deploying anything pod because pod do not have long life. Pods, they die easily. So you always deploy pods through deployments, stateful sets, replica sets, daemon set, as the case may be. All right. You won't be deploying pods directly. All right. But it's just to show you how it is, what pod is, and what its definition looks like. All right. So this is everything about pod. We don't need to go much detail about pod. All right. Because what we shall do later is more of deployments and the likes. Right. That's it. Very basic. So come over here, copy this guy, copy it, copy. Now go to your cluster. Okay, let me create a directory, mkdir, let me call it Kubernetes. All right. So go into K8 and create a file called pod.yaml. Take note, your YAML file has to have the extension .yaml. All your Kubernetes manifest must have the file extension .yaml. So open this file, paste it. Now, let's start explaining. So API version is the first line of your Kubernetes manifest, right? So this line defines the version of the API you'll be using. The next line is the kind of the object. The kind of the object is what? In this case, is a pod. Now, this next line is where you define the properties of the object. The properties of the object are defined under metadata. All right. So here you can define the name of the pod. You can define things like labeling, which is tagging. You can define things like annotations. All right. And etc. You can also define things like namespaces. You got that. So everything about the properties of the objects, the properties of the objects, of this object, of the kind, goes under metadata. Take note, guys. So now the name of this guy will be, let me call it Fleetsman pod. All right. Then this next section is the specification of the container. All right, the spec now of that pod. So in this pod, you have a running container, and the container must have a name. So I'll call it Fleetsman-pod. So that is the name of the container running inside of the pod. Then the image. So I'll also going to share this image with you guys. I will share this image with you guys. So this image, sorry guys. So Richard Chesterwood KS Fleetman web app Angular. Then pods is 50-50. It's optional. You can add it, you cannot add it. All right, it's optional, but that's okay if you decide to add it. All right, now escape, save, and quit. Now that we have created a manifest, now let's look at the next one, which is what? Running a pod. To run a pod now, we'll come over here and say what? kubectl apply. So this command, the apply command, is used to create. It's either apply or create, but a lot of the time you would be using what? Apply. Right? kubectl apply. Then you specify the file that has your manifest file. You call it what? This is the name of that file, right? So remember, in this file, we've not specified anything called what? Namespace, right? So let's say, for instance, I go back and say pod. Let's define namespace. So I'll come over here and I will say namespace. So namespace will be like, what should I call it? Demo. Or I can say Fleetman as the namespace. Escape, save, and quit. All right. I can also write a what? A manifest that creates a namespace. Let's see that. So what I will do, I'll go to Google and I'll say Kubernetes what? Namespace. Guys, everything you're taking it from that documentation. You don't need to cram anything. Know the process, know the flow. All right. I'm not doing anything out of my volition. I'm using the lay down what they have, what Kubernetes has. All right. So I'm showing us the path. I'm showing us the way, how to go about it. Okay. I'm not writing anything from, I'm not copying anything. No. So I'm following us the steps. So that when you'll be doing, it will help you. It will build you in that way. Right. So Kubernetes, then the object name, namespace. The first link, guys, right click on it, open in a new tab. Let's check how to create a namespace. All right. Now here's the manifest for namespace. Manifest. They don't have it in name. Okay. Creating a new namespace. Let me right click and open a new tab. Let's see if I can get something from there. Let's see. That's it, guys. Very simple. The API version is this. The kind is a namespace. The metadata is the name of the namespace. That's all. That's all you need, bro. That's all you need, bro. All right. That's all you need. All right. That's it. That's it. Creating a namespace. Okay. That's it. So close this guy. All right. So let's go there now. So now I'll create a namespace. Let me call this vim ns.yaml. All right. So in here, the API version is going to be what? v1. Calm down. The kind is what? It's a name. Look at the spelling now. Capital N, namespace. Then metadata. Metadata is, let me see something. Metadata. So metadata is specify the name of what? Of the properties of the namespace, the object. So the namespace is what? Fleetman. That's all, guys. Escape, save, and quit. Look at. We have two files. All right. Now, what do we now do? Say kubectl apply -f namespace.yaml, then apply another -f again, pod.yaml. All right. Now, if I hit enter, this guy is going to create for me. What's it saying now? Fleetman not found. Namespaces, Fleetman. Okay, want to create it first. So let's create it first. This error is coming from wait oh. At the call. Cat pod. And namespace. Fleetman. Cats ns. Fleetman. Name. Oh, thank you. No. For where? Which side? Oh, thank you, thank you, thank you. No. This is a pod now. The namespace is Fleetman. Then this is the name of our namespace, Fleetman. You know, see where? Hello, Chill.
But the name of the metadata is Fleeman.
For where? Where?
For up.
This one?
Uh,
No, the name of the pod. This is the name of the pod. Take note. The name of the object. This object is a pod, and the name is Fleetman pod. This namespace now, Fleetman. Where they confused again? You still confused? I'm not sure.
no, it's okay. Now we are for the confused with that because
No, you're not supposed to get confused. I told you something. This under metadata, you define the properties of the objects. The object here is a pod, and under metadata, you define the properties. The name of the pod is defined as this. The namespace in which we are going to deploy this pod into is defined as this. Please don't get confused. You must not get confused. So I need to create that guy first. kubectl apply -f namespace. Wait, so if you choose to ignore these errors, error by the ns. Wait, we have error in this file. We have error in this file. Namespace. Well, let me check. Let me check that doc. What's it saying? Now. API version, kind. Okay, we should use create. It wants us to use create. Okay. All right, so let's use create instead of apply. So kubectl creates -f namespace. All right. So Ogbeni API version is Z1. Oh, sorry. Sorry, guys. I went here and put capital K, now small k. Guys, take note, please. Now small k, right? So now small k. So kubectl apply -f ns.yaml -f pod.yaml. All right. So this has been created. All right. Take note, guys. Now, if I need to search for that pod, let's check. kubectl get pod. I'm not going to see it here. You can see now because that pod wasn't deployed into this namespace. Now let's check the namespace first. kubectl gets namespace. So I have what the Fleetman was namespace. Now let's check what are the objects in that namespace. kubectl get pod in namespace using the -n flag, then Fleetman. So I'll see that I have what a Fleetman, a pod running in that word's namespace. All right. Now, so far, there is no service associated with this pod. So it means that I cannot access this pod, this application from the outside world externally. All right. So the only way I can do what I can access this service is by exposing this guy through a service. All right. So that now brings us towards services in Kubernetes. Right. So services in Kubernetes, as the name implies, are used to access. They encourages pod-to-pod communication, right? So that's what they do, pod-to-pod communication. Now, there are different kinds of services, different types. We have, oh shit, we have cluster IP, we have node ports, then we have load balancer. So cluster IP, node ports, then load balancer. So in today's class, we are going to see these kinds of services. All right, great. So I want to create a service, then I'm going to attach the service to a pod. I'm going to link a pod to that service so that I should be able to, that pod will be able to communicate. Now, as this guy is now in this cluster, as this pod is now, this pod cannot talk to themselves. If I create another pod, let's run another pod based on what's that, my Frankie's Infotech slash Apache demo. Okay, so if I need to copy this guy into apache.yaml, now go into that apache.yaml, then change the image. Image should be Frankie's Infotech slash Apache demo v1. So this is my image that we used last time. All right, Apache demo. I pretty I still have this guy up there. So the name will be Apache ecom, sorry, is e-commerce. Ecom, the namespace, Fleetman namespace, no wala. The pod is ecom. Ecom. Escape, save and quit. Now say what? kubectl apply -f Apache. Now to tell me that this pod has been created. Now let's check it. kubectl get pod in namespace Fleetman. So I have two pods running in my in my namespace in this cluster. Okay, right. So let's check on which nodes are these guys running. So I'll say kubectl get pod in namespace Fleetman -o waiting o wide. So o wide is going to give me more details. So it's telling me that ecom is scheduled to run on what? Node number 1. All right. Then this guy is already running on what? Node. Okay, they are both running on the same. No. Okay, they are both running on the same node. All right. These guys are both running on the same node. Okay. Great. Now, as these guys are now, they can't talk to each other because there's no service, though they have IP address. All right. So I need to create a service so that they can start communicating. Right? Communicating. So it is a service that will expose this guy to either to other pods within the cluster. So for that, we're going to hop onto our Google and do our normal research. Google, our normal research, Kubernetes, then the service. So we shall start with cluster IP. So cluster IP, a service type of cluster IP states that if you don't want your objects to be accessed externally from the internet, all right, then assign those objects, those pod, a cluster IP. A cluster IP means that the service communication remains within the cluster. The service communication remains within the cluster. All right. This we did justice to all of these on that's our topic, Kubernetes objects. All right. So, like I said, go back and rewatch the Kubernetes objects so that you will get the feeling of what these objects are all about. So, with a service type of cluster IP, you don't want your ports to be accessed from the internet. You want the communication to remain within the cluster. So for that, we will go to our Google. Now say Kubernetes service. Your first link, open it. So let's look at the what's it called, the manifest. So this is the manifest, so simple and straightforward. So just copy it, copy, come over here and create a file, vim service.yaml, and paste. Now the API version is definitely v1. The kind is a service. The name of the service, so I can give you the name. Let me call it ecom svc. Ecom svc. Now, service uses a field called a subfield called selector. A subfield called selector. This selector is used to select the pod, the label on the pod that the service wishes to connect to. I come again, guys. It is called a selector because it is used to select the pod. It is used to select the label on the pod which the service wishes to connect to. Now, you have to make sure that the selector, the value of the selector, the key value of the selector matches with the key value of the label on the pod. Now, what am I trying to say? This is a service that I want to use to connect towards to the ecom pod. So for that, I will define a selector. I can call it any name, but you have to look for something that makes sense. So the selector name key is what? App. The value, I can call it ecom. Anything, but look for a name that makes sense. All right. This service runs on ports. It's a TCP protocol. It runs on port 80. All right. I don't need any target ports. Can remove this guy. Now you come down here now. Down. You specify the type. The type of that service is what? Cluster IP. That's all, guys. Make sure this guy, your selector here is app ecom. Escape, save and quit. Now I'm going to go into the label, what's it called? The pod for Apache. Well, let me rename this guy to ecom. Move Apache to ecom.yaml. So I've renamed it to ecom. So open ecom. Now, under metadata as the properties, I'll come down here. I'll define label. I'll say what? Labels. Column. I'll start defining the label. So the label for this pod is what? App column ecom. So the label on this pod must match the selector on the service. This is how you can link a pod to a service or a deployment to a service. Now, they'll always ask you in an interview, how do you link a service to a pod? Now you have a service. You have a pod. How do you link this service to this pod? Now, on this pod, you have defined something called label. And label has app, which is the key value, ecom. It's been defined here. Now, on the service does not have label. The service has something called a subfield called selector. It is a deployment. Every other object except service has labels. Service is the only object that has selector. Now, you come here and say select selector on service. This key value pair must match with the key value pair on what the pod for labels. Then these guys are set to what? To communicate with each other. Then you can see that we've successfully linked these two guys together. If there's a difference, there's then difference between selector and the label. These two guys will not communicate, and you won't be able to access they can't communicate. You can't link the service to the pod, right? So the only way to link the service to the pod is that the key value pair under selector and the key value pair under labels must match for service and what pod. They must match. All right. Great. Now let's go back now. So we've made them to match, right? I will escape and I will save. Now I'm going to apply kubectl apply -f service and ecom -f. Great. So it's telling me that service was created, ecom was configured. Now, but we did not create that service in our Fleetman namespace. So if I say kubectl get service, that thing was created under the what? The what's it called? The default namespace. So I want everything to be on one namespace, right? I want to maintain namespace now. So this is what I will do. I will delete this service. kubectl delete. All right. Delete what? Service by their name. The name of the service. Copy and paste. Deleted. This is one way of deleting a service. An object, sorry. kubectl get service. It's not there. Let me recreate it and show you another way. Another way of deleting that service. So let's recreate this. kubectl apply -f service. This guy has been created. So kubectl get service. Now I want to show us another way of deleting it. So I can delete it using the manifest. I'll say what? kubectl delete -f the manifest. So this guy is going to delete that service. You see now, I've shown us two ways. It's either you delete it by the name, kubectl delete the object name, or simple, just go to the file and delete it from the file. All right, take note, guys. Now I want to create this guy in the Fleetman namespace. So I'll go back to that service file. Then I'll specify my namespace. Come here. I'll say namespace. Namespace is what? Fleetman. Escape, save and quit. So this guy is going to deploy into the Fleetman namespace. So I'll say kubectl apply -f service. So this guy is created. So if I say kubectl get service now, I won't see it except I specify the namespace is what? Fleetman. Then I will see that service under the Fleetman namespace. So you can see the type of this service is what? Cluster IP. Cluster IP means that this guy cannot be accessed outside of the cluster. Communication remains within the cluster, right? So I want to change this type to what? To a node port. So that's cluster IP. So we can't talk. One second, guys. NG. Yeah, no, I call him. You call him back in the next 30 minutes. I'll call him back. I'll call him. Eh, eh, no wahala. No wahala, man. Thank you. Uh, all right, man. Sure, sir. Sure, man. All right, 1 second, guys. 1 second. 1 second, guys. I'm gonna check something. All right, guys. So now let's look at what creating what a node port. So let's come over here. Let's change that service type towards a node port. So now if I come here, let me copy and paste, then all right. So the type is what node port. Now, if I don't specify the value, the port number, which the port number range, I told us that node port is assigned from the range of 30,000 and above. If I don't specify the range, the Kubernetes service controller is going to assign to me a random port number from that range, 30,000 and above. All right, 30,000 and above. 1 second, guys. All right, so escape, save and quit. Let's apply. kubectl apply -f service configured. Now, if I say kubectl get service in namespace fleetman, you can see the service type has changed from what cluster IP towards node port, and it's giving me what a port number 31578. So via this port number 31578, I should be able to access this application externally, right? Externally. Now let's see what we can do. How we can access this application externally. So I'm going to look at the node which this pod is running, the ecom pod. So I'll say kubectl get what? Get pod in namespace fleetman. O what? O wide. So this ecom pod is running on what? 3.99. 3 dot what? No, sorry. Okay. Sorry, no. This is the port IP, guys. This is port IP. So this is the node. It's running on 10.0.3.195. So let's go to AWS and check for that node. 3.195. 3.195. This should be it. 3.195. All right, no, the next one. So this is 3.195. So copy the public IP. All right, here's the public IP. So copy the public IP that's been copied. Go to your browser. If I hit enter, I won't be able to access it, all right? Because it's not communicating directly on port 80. It's communicating on the node port. And that node port is 31578. So I'll come here and I'll say column 31578. I'll hit enter. Wait, stop it. Enter. 31578. Is it? 31578. 31578. So why is not going? Let's check. 31578. So okay, so this was happening, guys. This was happening. Now, this guy has a separate security group. Guys, watch you. Watch. It has a separate security group. If I go to security, look at on this security group. All right. On this security group, because by default, EKS cluster is not you're not supposed to access any objects on that cluster. All right. So this guy is pointing to itself. You can see this security group is the same thing here. The same thing here. So it's pointing to itself. So I may need to edit this security group. All right. So I'll click on this guy. I'll edit inbound rule. And I'll add the rule. So I can add a custom rule for that particular port. 31578. Custom. 31578. Custom. Anywhere. I'll click on save. Save. So once I go to my browser, just watch you. You can see. Because I have exposed this port through my firewall, my cloud-based firewall, I've been able to access this application. Because look at now, this worker node came with a security group, right? But you can attach a security group. So you can decide to remove that rule, edit inbound rule. Let's delete that rule. This rule, right? Delete it, delete. Save your rules. It has been saved. If I come back here and refresh this site will go off. All right. It's not working again. Don't worry. Come back now. Let's attach a security group. Rather, I'll go to instances and I'll pick that instance, which is this. Then we have only one security group, right? Yeah. I'll go to actions, instance settings. Where is this thing done from? Wait, oh, it's done from somewhere. It's done from somewhere. I go. Oh, security, sorry. Security. Select the instance, go to actions, come to security. Then you can say what? Change security group. Click on change security group. All right. You can attach, you can add more. I don't want to remove this guy. So I can add Frank SG. I can add security group. I'll click on what save. So this my guy. Watch you. This site will go back now. It will go back to normal. I see it now. It is now normal now. Because on Frank SG, where is that place? So this instance now has two security group. If I go to security group now, so it's communicating through security group. So on Frank SG, I have opened all the ports. I've shown you two ways, guys. The first way was modifying this security group that the worker node came with. The second way is by attaching your own security group to it and expose the ports. All right. So that is it, guys. All right. Great. So we can access this application externally. Now, this is something now. Here's the catch. If CO QCTL gets service, Fleetman, if I redeploy this service, this port number will change. If I say QCTL apply -F service. Okay, it's not changing. It's not changing. Let me go into that file. Go into that file, service. Let me just remove one line. Remove one line. Let's save it. Let's add one, save it. If I apply now, apply. No change. Okay. It means that if I delete and if something happens, let's say kubectl delete -f service. Now, if I recreate it now, apply. Now check the service now. kubectl get service in namespace fleetman. The port number has changed. You can see it now, 32407. So if I refresh here, I've lost connection. So you see the challenge with using node ports if you don't, if the port number is not hard coded. All right. So let's see how we can hard code the port number instead of leaving it for the service controller to be assigning a random port in the range of 30,000. So 32407. 32407 is back up. Now, let's go and see how we can what? Attach what? Affix a port number. So I'll go to service. So I'll come here, node port. I'll come on the ports subfield. There's a subfield called node port. So this is used to specify the port number that you want for this service. I can say 32,000. So going forward, this will be the port number. All right, default node port number. So you can say kubectl apply -f service. So that's been configured. So if I say kubectl get service in namespace fleetman, so you can see this guy has changed. If I come here, I refresh, service is gone. So I can come here and change it 32,000. It is back up. All right. So great. Now we can actually edit a service on the go, on the fly. How do we do it? Now let's check now. Assuming now I change this thing back to cluster IP. Watch you. I say service. I come here. I change this guy back to cluster IP. Then I have to remove this guy. All right, escape, save and quit. Let me apply kubectl apply -f service. Now kubectl get service namespace fleetman. You can see this guy can't access it from the outside world. If I refresh, so everything is down now. Now let's say, for instance, naturally this service was set up as what? A cluster IP, but you just want to check what will this application display on the browser. You don't want to go and change the service configuration to node ports and start doing all those boot. All right, you can just edit it on the fly. How do we do it? You can say kubectl edit service. The service name now ecom svc. In which namespace? Fleetman namespace. Look at now. I want to edit this service. So I'll use the word, the edit parameter. kubectl edit service, then the service name. So you hit enter. So once you hit enter, you're going to see the manifest, everything that was defined. So I'll come here. I'll come to type. See you. Can you see the type here? Let me set line number. Line number 31. The type is what? Cluster IP. I'll change this guy to node ports. I'll edit it. I'll go into edit mode. I'll say what? Node ports. I'll delete it. See, this is, you're just doing this thing on the fly. If you redeploy this guy now, this changes that you made is not permanent, it's temporal. You just want to check for something. All right, escape, save and quit. What was it saying now? Save now. A copy of changes has been stored to these. No valid changes were made. All right, let's go back to that guy. He didn't save it. Let's go. Spec. Okay. Cluster IP. type is node ports. Node ports. I'll come here and define. It's supposed to give me randomly. So internal traffic policy cluster. I think that's all now. This is just a cluster IP. Why no save now? All right, so let me do something here. Let me say node ports. Let me see if it fly. Go node ports 30,080. Escape and save. All right. So let's go back there. Let me show you what I did. Go back there again. Edit. So you see what I did. So I changed the type from cluster IP to node ports. Then I came over here and I specify the flag node ports. Then I gave it a value. All right. Then I escape. All right. I did cancel. So if I now say kubectl get service in namespace fleet man, we should have this guy. But this setting is what is temporal. It's not permanent. All right. So I'll come over here. 30,008. 30,080. So temporarily, I'll be accessing this guy. But it's not that that guy is permanent. Because the moment I say kubectl apply -f service, it will override everything. Now kubectl get service. That's come back to what? Cluster IP. So this is how you link up your service to the port. So now let's write another service for our Fleetman pod. So I will call that okay, let me rename this guy service to ecom service ecom dash svc.yaml. All right, so I've renamed this guy. Now I also create another service. So copy ecom service to Fleetman svc.yaml. Copy. So go into Fleetman svc. So the service name is Fleetman svc. Fleetman svc-svc. The namespace is Fleetman. Selector is app Fleetman. Then okay, I needed to show us the last service type, which is load balancer. I'll show us the last service type. So cluster IP, that's okay. Okay, let me just go direct. Node ports. All right. 2000, escape, save and quit. All right. So now I'll go to what? If I apply this guy now, see, apply -f Fleetman service created. kubectl get service in namespace Fleetman. All right. I have this guy running on this guy. Now, if I check kubectl gets pod in namespace Fleetman. O wide. I want to access that Fleetman pod. O wide. Let's check. So this guy is also running on the same 3.195, right? It's running on port what? 32,000. So I'll come here. I'll say what? 32,000. 32,000. The site is not coming up. Do you know why it's not coming up? Is there any reason why it's not coming up, guys? Yes, no time. What have we not done? What have we not done? Any suggestion, any input? Toby, it's not coming up. It's not coming up. The pod, the Fleetman pod. Dotun,
Boss, I did with you.
any suggestion? Why it's not coming up?
Yeah, initially we added to the security this thing on the AWS. I feel that we need to redirect it.
No, I don't think that's it, because I have added my security group now. So that's not the challenge. Frank SG. I open
Okay.
all ports. So everything is
Okay.
communicating. So why is it not coming up? Because guys, I've not updated this guy now. This pod. I told us now. For you to link the service to a pod, you must set selector and labels. Always be alert. If you are having a complaint that the pod is not coming up, even when you've done everything, always come back and check the label and selector. Check the label and selector, guys. Those two things must match. If those two things do not match, I'm sorry, the pod can never come up. You can never be able to access that pod externally. All right? You can never be able to access it externally. I had an opportunity I had to interview with one European company once. They gave me live scenario. All right? Very live. The guy told me that they have a service in their cluster. That service, they cannot access it. That I should troubleshoot the service to make sure that the service is accessible on the browser. I just smile, but there is more to it. I had to, first of all, I checked. I was getting image pool error. I knew that there was a problem with the image. So I had to open the manifest file. I copy the image. I copy this image like this. I copy them. As I copy this image, copy, exit. And now use Docker. Though I don't have Docker on this machine. Let me just install. Let me just show you what I did. Install Docker. So I searched for that image. And I corrected it. And I realized that I wasn't even getting the image. Sudo user mode Docker EC2 user. All right. So now do system. And I do what? A Docker search. The image name. Sorry, I removed that 0 now. I hit enter. Exit and come back. I did the Docker search. Remove that 0. It didn't show me anything. All right. So I now, what did I later did was it didn't show me anything as well. I come Docker search. Why is the so this guy still get this info up? Make it release. But anyway, I did Docker search and I saw the image, the real image, and I corrected the image on the manifest. I apply it, but still that error went off. But still, I could not access the application. So I now went towards, and I went to this section. The label here, labels app Fleetman. The label here was different from what we have on the service, on this and the selector on the service. All right. So this is how you always try and troubleshoot. Okay. Escape, save and quit. Let's check the service. Cat Fleetman service. App Fleetman. Now we should be able to, we should be fine now. kubectl apply -f pod has been applied. Now, if I come here now, if I refresh this guy, refresh. Can you see, guys? We are now able to access the application. This is the application, right? So far, this is what node port. Now let's wrap today's session up with what? A load balancer. All right. So I'll just go to my manifest. I'll come here. Let me go to that Fleetman service. So instead of a type of node port, I'll say what? Load balancer. I'll delete. I will escape. I will save and quit. I will apply. kubectl apply -f Fleetman service. Apply. Now kubectl get service namespace Fleetman. Now look at the difference now. A load balancer is going to create for you an external IP. All right, followed by a node port. This node port is optional, but you can, all right, if you don't specify it, the service controller is going to randomly assign a port in that range. Now, a load balancer uses what? A node port in that range. So if I say kubectl get service, I should see a random. Why is it? What's his problem now? Why is he giving me this guy? Why is he giving me that guy? All right, no wala. Tie 2000. Now, see, I'll go to AWS. I'll go and find this load balancer. I'll copy this guy. I don't need to even find it. Copy. Copy. Go to your browser and hit that guy. Enter. So this guy should have your web application. So this is your external IP. So with this load balancer, I can now create what we call a DNS in Route 53. You can see. So what I will do, simple, straight and forward. I'll just go to Route 53. You are through, guys. Duplicate this page, duplicate. Route 53, sorry. Route 53. But before I go to Route 53, let me show us that load balancer, right? Let me show you this load balancer. So I'll go to EC2, all right? I'll scroll down, I'll come to what load balancers. Then I will search for that load balancer. See it here now. If I search for it now, this is the load balancer. Open this load balancer. You can see it's running on port what? 32,000, right? So this is the load balancer. So I'll go to what Route 53 and I'll go to hosted zones. Oh, sorry, I go click on create. Hosted zones, don't create. Oh, I don't have any hosted zone here. Okay. All right, guys. I don't have any hosted zone. Maybe next time, right? Next time I'll use an account that has hosted zone. So this is it, guys. So this is how you expose your services as cluster IP, node ports, and load balancer. All right. But when we get into ingress controller, because now if I want to create, see now, I have exposed this Fleetman service towards as a load balancer, so that I can able to access it from outside the network, outside the cluster with what? The external IP, which is this. If I now go now and edit this ecom service, change the type to load balancer. Escape. Save and quit. Keep it here, apply. -F. Ecom Fleetman. Keep it here, get service. Namespace. Fleetman. You can see I have another load balancer. I'll copy this guy. Go to my browser. I'll hit enter. It will come up, don't worry. It takes time. It takes time to provision to come up. Come to your EC2, load balancers. You have another load balancer. It's provisioning. Just wait. You have 2 here. You can see now you have 2. So one is provisioning. So let's do it again. Should come up. I mean, you don't change anything. Why is it not coming up? Service, I'm not changing anything now. Why? Load balancer. AF. Why is it? Okay, let's try and see. Reload. All right, so you see, it's coming up now. It was still provisioning. It's up now. So it means that if I'm exposing my services as load balancer, it means every service, every Kubernetes service will have a corresponding load balancer. This method is not sustainable. This method is not cost effective because load balancers are not free. On AWS, load balancers are not free. They charge for these things, all right? They charge. So the only way to curb this process, this behavior, is by setting up an ingress controller. So an ingress controller, I will have a single load balancer whereby all of my services will be load balanced behind the load balancer. So the load balancer will now be doing the routing via an ingress rule, right? Maybe when we get to that stage, we shall show us how to set up ingress controller in your Kubernetes cluster, right? So I will be changing these guys back to, no need, I've got deleting everything, right? So once you delete, it will delete the load balancer from AWS. So if I say kubectl delete -F ecom service. So this is service, right? Service deleted. So if I come over here, one of these guys should go off. Are you see now? One of them is now deleted. So this is it, guys. So far, so good, guys. We've been able to talk about what's it called? Where's my board? The 3 types of what? Services: cluster IP, node ports, and load balancer. The cluster IP encourages internal communication within the cluster. Node ports and load balancer encourages external communication outside of the cluster. All right. So far, so good, guys. I think we've brought today's session to a close. Before we finally wrap it up, is there any question? Is there any question? All right. If there's no question, assignment. So this is the assignment you do for me. You are going to set up an active MQ pod and service in a Kubernetes cluster. All right. All I need to see is once you set it up, that moment, send me the URL. Send me the what? The public IP and the port number. I'll just view it. Once I view it, I'll tell you delete the cluster. All right. So I need to see this page. ActiveMQ is a message broker. You can read about it. Go to Google. ActiveMQ. Most commonly deployed as standalone process. Isolate went from the what is it? It's an open source message broker. It's like Kafka. It's a message broker written in Java together with full Java message. It provides enterprise features, which in this case mean now what is ActiveMQ used for? ActiveMQ, active message queuing. It's a queuing service. It's an open source protocol developed by Apache, which functions as an implementation of message-oriented middleware. Its basic function is to send message between different applications, but includes additional features like ST, STORM, JMS, and OpenWire. So ActiveMQ is a message broker. It's used for sending messages between different applications. So the assignment is, I want you to deploy this guy, all right, on the cluster. I don't know where you're going to find your image. You have to find your image, all right? You have to what? Find your image. You use a Docker image. It's on Docker Hub. ActiveMQ is on Docker Hub. So go there, you get the image, you get the version, you deploy your cluster. I want to see this guy latest tomorrow. Latest, if it's possible this night, give me this night. So far, so good, guys. I want to bring today's session to a close. Is there any question about the assignment? Any question? So I'll leave this far off. I'll leave this guy. I'll just delete the cluster. Any question, guys? Cluster. Worker nodes. All right.